Good morning, and today we'll be looking at condition for tangency. So to determine how many times a line intersects a parabola, we substitute the equation of the line into the equation of a parabola, and then what we do is we're creating a combined quadratic equation. We then use the discriminant of this combined quadratic, we called it here the resulting quadratic, to find the number of intersections. When we're finding the discriminant of just a quadratic, we're finding how many times the quadratic meets the x-axis. When we combine a line with a parabola, and we then use the discriminant on this resulting quadratic, we're finding how many times the line meets the quadratic, the parabola. Okay? So if we have the equation y equals x squared plus 2x plus 2 and y equals 2x plus 4, if we make them equal to each other, then gather everything over to the left-hand side and gather all of our x's and our constants together. Here we have a combined quadratic, which is x squared minus 2. Now, if we solve that and use the a, the b and the c on the discriminant to find out what the discriminant is, we can see here that the discriminant is 0 squared minus 4 times 1 times negative 2, which is 8. So the discriminant is greater than 0. Now, that is the discriminant of the combined quadratic. That means that this line meets this parabola twice because the discriminant is greater than 0. And that's what it looks like, just for you to visualise what we're talking about. Here we have the parabola, and here we have the line, and we can see that there are 2 points of intersection, and the fact that the discriminant is greater than 0, it tells us that. It doesn't tell us where the 2 points of intersection are. We can just see that from the graph, but I wouldn't have got that from my working. I'm just showing you that for information. All we would know is that there are 2 points of intersection because when we combine the two together and get a combined quadratic, the discriminant of the combined quadratic is greater than 0, which tells us there are 2 points of intersection. Here we have an example. We'll merge these two together, just as we did before. And we solve this. The discriminant is equal to 0 squared minus 4 times 1 times 0, which is equal to 0. Now that's a combined quadratic resulting in a discriminant being equal to 0. That means that the roots are real and equal, meaning that there is one real root, meaning that the line and the quadratic meet once. And this is what it would look like in a graph. Now that means that if the line and the quadratic meet once, that means that the line is a tangent to the quadratic, the parabola. It's a tangent to the curve. If you have a line meeting a curve at one point only, that's you have found that it is a tangent to the curve. And here we have another example. Again, you're not copying any of these down, just to demonstrate. Here's the parabola and here's a straight line. Let them equal to each other. Gather them together on the left-hand side and we put them into the discriminant. So we have b squared minus 4ac. What does that equal? 0 squared minus 4 times 1 times 2, which is negative 8. Now, when the discriminant is negative, that means that there are no real roots, no points of intersection. Okay? So the line and the parabola do not actually intersect. That's what that tells you here. So let's look at this graphically. Here we have the parabola and here we have the line, and as you can see they don't even meet each other, and the discriminant being less than 0 proves that. So we can use the line and the parabola and create a combined quadratic and then use the discriminant on the combined quadratic. And then when we use that, we can identify if the discriminant is greater than 0, it means that the line meets the quadratic, the parabola, twice. If the discriminant is equal to 0, then they meet once and it is a tangent. And if it's less than 0, the line doesn't even meet the parabola. Okay, so here we have the note to copy. For the quadratic equation formed when the equation of a straight line is substituted into the equation of a parabola, if b squared minus 4ac is greater than 0, the line and the curve intersect twice. So it's the same idea as we had before when we knew then that the quadratic, the parabola, would meet the x-axis twice, but this time it's that the parabola meets the line twice. If it's equal to 0, that would normally have been one real root. Roots are real and equal, one root. So it means then that the line and the parabola meet once. There is a tangent to the curve. Okay, so if you're ever told something about there being a tangent to the curve, you know then that would mean that the discriminant would be equal to 0. The discriminant is less than 0. That would normally be no real roots. That would mean in this context that the line does not even touch the parabola at all. They do not even intersect. Okay, so here we have an example. Show that the line y equals 5x minus 2 is a tangent to the parabola y equals 2x squared plus x, and find the point of contact. So the first thing we're going to do is combine these two together. Substitute y equals 5x minus 2 into the quadratic, which is y equals 2x squared plus x. Okay, so we have 5x minus 2 equals 2x squared plus x. Now, what we've done here to gather these together is I've actually brought the 5x over to that side and the negative 2 over to that side, which has made it 2x squared plus x minus 5x plus 2. But I've just written it on the left. And we could have also started with that one on the left and that one on the right and brought it all over to the left that way. So we gather everything together, which leads to 2x squared minus 4x plus 2 equals 0. And we're asked to show that the line is a tangent. So we're now going to put this into the discriminant. If you're asked to show that a line is a tangent to a curve like this, okay? So A is 2, B is negative 4, and C is 2. So we're going to put that into the discriminant. Okay. And we happen to get 0. But we also then need to be able to write the conclusion. Because we know that the tangent is equal to 0, the discriminant is equal to 0, that then means that a tangent, the line is a tangent to the curve. So b squared minus 4ac is equal to 0, so state that again. So there is one point of intersection and the line is a tangent to the curve. Okay, and that's you proving it using the discriminant. There's a second part to the question, and find the point of intersection. So this is the combined quadratic that we have from the straight line being equal to the quadratic, the parabola that we had to begin with. So this is our combined quadratic that we're now going to use. So to find the point of contact, we're going to now solve this combined quadratic. Okay, so that's again the combined one. So we're now going to factorise it, take out our common factor, then put it into our double brackets. We would be expecting to get the same bracket twice because there is only one point of intersection, remember. So x is equal to 1. So we have 2 times x minus 1 times x minus 1 equals 0. Remember, it's not the 2 that's equal to 0. That's why the 2 disappears. But it's the x minus 1 part that could be the thing equal to 0. So we have the same bracket twice, so we just have x equals 1. Now, that's us got a half of our coordinate. X is equal to 1. If we want to find out what the second part of the coordinate is, which is the y part of the coordinate, we're going to substitute it into either something that begins with y equals the 5x minus 2 from here, or y equals the 2x squared plus x from here. If we are substituting an x into a y equals equation, you're going to find the y part of the coordinate. So we've used the simpler one, which is y equals 5x minus 2. 5 times 1 minus 2, which is 3. So we've now worked out that when x equals 1, y equals 3. So the point of intersection is 1, 3. And we did that by creating a combined quadratic from the line and the original quadratic being equal to each other, and then solving that combined quadratic. And the point of intersection is 1, 3. Okay. Right, so here's a slight different question here. Find the equation of the tangent to y equals x squared plus 1 that has gradient 3. So I'm telling you this time the gradient is 3. Now we know that the equation of a tangent is an equation of a line, and an equation of a line is y equals mx plus c. We know that the gradient is 3, so we can put that 3 in front of the x, but we don't know what that constant is on the end. So we'll call it k, just for the purpose of not getting mixed up with the letter c that we're going to be using from the discriminant. So we're going to have a general equation of the tangent, which is y equals 3x plus something. And all we need to find is what that something is on the end, and that's us got our equation. So we're going to do it again, substitute y equals 3x plus k into your quadratic, merge them together, bring everything over to the right, and then swap your sides. So we have x squared plus 1, and then a minus 3x, a minus k, and make it equal to 0. Now look what we've done here as well. We've rearranged it, so I've got my x squared first, then my x, and then my two constants, my 1 and my minus k, are last. So they will all be that c value in the discriminant. Now, find the equation of the tangent. It starts off with the question saying find the equation of the tangent. So we know the equation of the line is a tangent, so we can make the assumption that the discriminant is equal to 0. So we're going to identify our a, which is a coefficient of x squared, our b is the coefficient of x, and our c is the part on its own which doesn't have an x or an x squared, so it's a 1 and a minus k. Put it into the discriminant, but we know it's equal to 0, so we've brought in the equal to 0 right away. Okay, now we tidy all that up. So that leaves us with a 4k equals, so that was a 5 on the left there, and we bring it over and make it a negative 5. So the value of k is negative 5 over 4. So that means that that's what the end part of the equation of the line is, negative 5 over 4. So the equation of the tangent is, we knew it was as much as y equals 3x plus something because we were told the gradient is 3. We've now worked out that the k value is negative 5 over 4, and that goes in there, and that's our equation of the tangent to the line. Okay, so we're now ready to look at exercise 8J. We have our selection of questions here, and as always, ask your teacher if you need any help. Take care and good luck.